Hello, today we'll be discussing the light-dependent reaction in photosynthesis. To begin, the light-dependent reaction occurs within thylakoid discs, which are within the chloroplast of a cell. Surrounding these thylakoid discs is a fluid substance called stroma. So here, what I have is what would look like if we cut a thylakoid disc in half. In each thylakoid disc, we have photosystem 2 and photosystem 1, which is what absorbs light photons. Within each photosystem, we have chlorophyll A, and surrounding chlorophyll A, we have accessory pigments. So, chlorophyll A absorbs light photons, and whatever does not get absorbed by chlorophyll A gets absorbed by the accessory pigments. The accessory pigments also bring these photons to chlorophyll A. These absorption of photons causes chlorophyll A to have its electrons excited, which causes it to lose its electrons. However, chlorophyll A does not like being without electrons, so this is where water comes into place. Water loses its electrons to chlorophyll A, which then causes the water bond to break. This produces oxygen and hydrogen ions. Oxygen leaves the thylakoid, it leaves the chloroplast, it leaves the cell, and leaves the plant through the stoma. The hydrogen ions stay within the thylakoid, increasing its concentration. So, the electron is excited and leaves photosystem 2 through an electron acceptor molecule, and it moves down a chain down to photosystem 1. However, at each step in the chain, the electron loses energy. This loss of energy causes hydrogen ions to be pumped into the thylakoid. Hydrogen ions get pumped into the thylakoid from the stroma through a hydrogen pump. This increases the concentration of hydrogen ions within the thylakoid. There is only one way for these hydrogen ions to leave the thylakoid, and that is through this. This right here represents an ATP synthase enzyme. So hydrogen ions leave through the ATP synthase enzyme. However, that is not the only thing that occurs here. As hydrogen ions leaves through this enzyme, it makes it so that ADP and a phosphate ion bind. So, let me repeat it one more time. As hydrogen ions leave through the enzyme, ADP and phosphate ions bind to make ATP. ATP is an energy currency molecule. So, let's get back to this electron molecule. So, this moves down the chain, and then we get to photosystem 1. Photosystem 1 gets hit by light also. Chlorophyll A absorbs the photons and loses its electron. Chlorophyll A is without an electron, and it has no water molecule to take away the electrons. So that's where this electron comes into play. This electron gets absorbed by chlorophyll A. This other electron here that got lost in chlorophyll A in photosystem 1 also leaves through an electron acceptor molecule. However, the electron acceptor molecule does not want to keep this electron, and this is where NADP plus hydrogen ions go into effect. NADP plus hydrogen ions take, as another word is to use, take the electron molecule, the electron, forming NADPH. The role of NADP plus hydrogen ions is to become an electron carrier, which, as it does, it becomes NADPH. So, the light-dependent reaction has one input of water, and it produces three outputs. It produces oxygen, which leaves the plant completely, and it produces ATP, which is an energy currency molecule, and it produces NADPH, which is an electron carrier. Well, NADP plus hydrogen ions is the electron carrier, and once it does, it becomes NADPH. This is the process of the light-dependent reaction, and NADPH and ATP move on to the light-independent reaction.